In this video, I'll show you how to solve the ALEKS problem called dosage calculations using patient weight. This is a unit conversion problem, and it is actually a really tricky unit conversion problem. There's quite a few steps that you have to go through to get to the answer. So I'm going to start by taking the information out of the problem and just writing it down so that we don't have to read through the problem anymore. First of all, it tells us that we have a 45 kilogram patient. I'm going to write that down. It tells us that the patient needs medication, and the dosage of the medication is 3 milligrams of drug for every kilogram of person or patient. So 3 milligrams of the drug for every 1 kilogram of the patient's body weight. That is the dose of the drug. The pharmacy has a solution that is 250 milliliters, and in that solution, there's 1 gram of the drug. We're going to write that as a conversion factor as well. So we're going to say that we've got 1 gram of that drug in a 250 milliliter solution. And you're going to have something similar to this in the problem that you're solving. It's going to tell you how many grams of the drug are present in a certain volume of solution, and you need to write that as a conversion factor. And then last but not least, it wants us to calculate how many milliliters, so the problem that we're trying to figure out, how many milliliters of the solution is needed for this 45 kilogram patient. So now that we've got all the information written down, all the information we need to solve the problem, the first thing, well, let's kind of think backwards. It's asking us how many milliliters of this solution do we need. The amount of solution we need is based on how many grams of the drug we need. The amount of grams of drug that we need is based on the size of the patient. So working forward, we need to start with the size of the patient, 45 kilograms. I'm just going to use the letter P for patient. And we need to figure out, using this conversion factor, we need to figure out how many milligrams of the drug we need for that size patient. That conversion factor tells us that we need 3 milligrams of the drug for every 1 kilogram of patient. Doesn't matter who the patient is. So we can cancel out the kilogram patient unit. Do the math on this. 45 times 3. This tells us that we need 135 milligrams of drug for this particular 45 kilogram patient. Now, let's go back and think about what we're trying to figure out. We're trying to figure out how many milliliters of solution we need. The amount of solution we need is based on how many grams of the drug we need. We know how many milligrams of drug we need. We don't know how many grams we need. So our next step is going to be to convert milligrams of drug into grams. Now, when I've looked at this problem on ALEKS, not every problem has the same units as my problem does, so you may not need to do the unit conversion that I'm about to do. Keep an eye on your own units, convert your own units as needed. I need to do a unit conversion because my quantity of drugs is in units of milligrams, but my ratio between the drug and the solution requires it to be in grams. So I'm going to do a conversion factor. I'm going to convert milligrams of drugs into the grams of the drugs. And I'm going to do this just doing a milligram to gram conversion. So I want my milligram unit to be on the bottom so that it cancels out. Milli is the prefix for 10 to the minus 3, which means 1 milli of anything is 10 to the minus 3. And that's going to cancel out that milligram drug unit. And I am going to get 0.135 grams of drugs. Now let's 1.135 grams of the medicine that the patient needs. Now let's go back and think again. What are we trying to figure out? We're trying to figure out how many milliliters of solution we need. The amount of solution we need is based on how many grams of the medicine we need. And this is the relationship between the grams of medicine and the milliliters of solution. So we've got one more conversion to do. We know that we need 0.135 grams of this drug. We need to multiply by a conversion factor that has grams of the drug down on the bottom so that that unit cancels out. and milliliters of solution, I'm just going to abbreviate that, SOLN, milliliters of solution on top, because that's what we're trying to convert into. This is the conversion factor that we need to use, but this conversion factor in this format is not laid out correctly for us. We need grams of drug on the bottom, and in this version of the conversion factor, grams of drugs are up on top. We need the milliliters of solution on top, and in this conversion factor, it's on bottom. Remember, with conversion factors, you are allowed to flip-flop them, turn them upside down, like that's totally valid. So we can take this conversion factor and we can just turn it upside down. Like that's absolutely allowed to do. So there's our new conversion factor written in a way that works for us. 250 milliliters of solution for every 1 gram of drug. We've got one more math step to do. This, like I said, this is a pretty tricky problem. It's got a few different steps to it. Keep an eye on the units and solve the problem following this general format, and you're going to be fine. It wants us to round the answer to the nearest milliliter. I got 33.75. If I round it to the nearest milliliter, that's going to be 34.